Hello, and welcome to Project Miira. In the last episode, we covered parasites as well as the depths. This time, we will go over the intertidal zone and then transition to land. Tides are determined by moons, of which Miira has one, Neros. Neros is slightly larger than our own moon, having a 10% larger radius and is roughly the same distance from Miira as the moon is from Earth. Its density is 50% more than our own moon, which means that the tides of Miira will be quite large, 2.5 times larger than Earth's, allowing for an easier transition to land. The first thing to become semi-aquatic is Malophylus. It may disperse its gametes, this time with the intention to spread to the unexplored beaches of Miira. Its leaves may lengthen and stiffen to absorb more light and stand firm when the tide is low. The roots may multiply to absorb more nutrients, allowing it to grow much larger than Malophylus, up to 10 centimeters in height. This plant-like life form will be called Rhizophilus, or grass plant. When Catherostoma transitions to the intertidal zone, it will be spending less time in the water. With its spiracles, it will easily be able to get oxygen from both water and air. However, its exoskeleton, made of aragonite, is too unstable to bring out of the ocean. For this reason, it may adopt chitin as a replacement. Chitin, found in arthropod exoskeletons and fungi on Earth, will be much better suited for a semi-aquatic animal. Inside its gut, it may develop a kidney to better filter water. Its circulatory system may expand to better transport oxygen to the rest of the body. Its shape may become rounder, allowing for greater mobility both in water and on land. This change to a more crab-like form is known as carcinization, which has happened numerous times before on Earth. Unlike Earth crabs, however, this creature will feed almost exclusively on Rhizophilus. This creature will likely breed and lay its eggs in the ocean, just outside the intertidal zone. The young will emerge as a miniature version of the adult, and may grow to be 8.5 centimeters wide, with its legs reaching lengths of 10 centimeters on average, before dying around the age of 3 years. It would have likely weighed, at most, 1.5 kilograms. Due to carcinization, this creature will be known as canceriform, or crab form. As Catherostoma emerges from the ocean as canceriform, Phylphagus may follow. Its fins may stiffen, forming bone, and it may develop a girdle to allow for better land movement. Internalizing its gill structures will allow it to keep them hydrated while on land, forming a primitive pair of lungs. To power its lungs, it may develop a group of muscles specifically designed to inflate and deflate them. This will be the beginnings of a diaphragm. These lungs, however, will be barely functional, due not only to the gills still adjusting to land, but also because its diaphragm will not be fully developed, meaning this creature will not be able to stay on land for long and will be heavily dependent on the ocean. They will be connected to the digestive tract just behind the mouth. A flap may develop, closing the breathing passageway when food is being swallowed. This will be a sufficient method of separating the passageways. However, if the creature were to attempt to swallow and inhale at the same time, it may choke. Its eggs will continue to be laid outside of the intertidal zone, and when they hatch, the young will stay in the ocean until they are fully mature, feeding on small tachypod and Calyphosoma. When fully mature, this creature may grow up to 1.5 meters in length and may live to be 6 years old. This is a drastic change in lifespan from its previous form, which was 15 years, but it is because the creature may still suffocate on land if it gets too big. It may not have strong enough limbs to drag itself back into the ocean, and the weight of its body on the still developing lungs may have an adverse effect as well. For these reasons, this creature will not exceed 1.5 meters in length and 65 kilograms in weight. We will call this creature pteropod for its land foot. Rhizophilus will not be alone in colonizing land, as Rhizophilus will adapt to the intertidal zone by stiffening its leaves to better absorb sunlight when the tide is low. This change will allow Catherostoma to transition to the intertidal zone. To better grasp the leaves of Rhizophilus, its front fins may adapt to be feeding appendages. Its remaining fins will become primitive legs, and its tail will shorten. The gill structures will be internalized, this time creating a new set of openings on the sides of the body. This will allow the creature to have its lungs near its heart without a long passageway that may cause choking. A pair of weak diaphragms will form beneath the new lungs, allowing it to inhale and exhale. Though its diaphragms may be individually weaker than pteropods, having two makes them around 50% more effective at drawing in air. For this reason, its gills will quickly develop the ability to take in oxygen from the air, allowing it to grow to be quite large, up to 1 meter in length and 45 kilograms in weight. Because it is capable of spending more time on land where there are less predators, the female may internalize her egg structure. When fertilized, these eggs will develop inside the mother's body in a cavity connected to the intestinal tract. The young will grow until they are large enough to have developed their lung structures and will be subsequently birthed in the ocean. Because this creature will give live birth, it will fall on one or both of the parents to protect and raise the young to ensure survival. In this case, the male will develop larger mandibles to better defend his offspring. The female will leave to find another mate and continue the cycle until she dies 8 years later. Litter sizes may range from 2 to 6, and the survival rate of the young is quite high. This creature will be known as Phylphagus, or plant eater. Catherostoma, being the ocean's most prominent predator, may follow its prey up to the shores of Miira. It too will need to adapt to breathe air, and so may internalize its lungs in the same fashion as pteropod. To better process toxins coming into its body, the creature may develop a primitive liver. It will begin as a second stomach, but then specialize to process and remove toxins. Unlike pteropod or Phylphagus, the female will lay her eggs in the intertidal zone. To do this, she must encase her eggs in a hard substance to prevent them from drying out when the tide is low. She may do this by using calcium carbonate, a common substance found on Earth as well as Miira. Her clutch sizes will be small, only 2 to 4, which will allow for larger eggs to be laid, in turn allowing for her offspring to hatch with all bones and organs fully developed. The female will protect her offspring from pteropod with her mandibles, who may occasionally attempt to eat the smaller prey. Springtime may become this creature's mating season, as the increase in local temperature will make it more active during this time. The males may prefer to avoid others of the same species until mating season arrives, in which case they will participate in procreating with a suitable female. Its young will live to be 5 years in age and can grow up to 1.25 meters in length and weigh 60 kilograms. This creature will be called a Formapod for its pouncing foot. Rhizophilus may adapt to a fully terrestrial life. It may do this by spreading its gametes during low tide to the cliff faces on the shores of Miira. The gametes will cling to the rock surface via a sticky substance called mucilage. Mucilage is found on Earth in carnivorous plants and in aloe vera plants. While it may be used differently on Earth, on Miira it will be a suitable substance to anchor the new plant's gametes to the cliff faces. The plant itself will grow tall with long narrow leaves, and its roots will grow sideways. This will allow the plant to stay attached to the rock wall, while also keeping it flexible enough to withstand the strong winds of the seas, much like palm trees on Earth. It may reach up to 2 meters in height. Known as a Neros, this plant will be named after its ability to climb. There is now quite a bit of decaying material on Miira's shores, with nothing to clean up. This is where Malophylus comes in again. Instead of continuing to feed on Rhizophilus and Astrophilus, this new plant will grow to depend on death and decay for nourishment. Its roots may become enlarged to better devour detritus, and its leaves may shrink as it will rely less and less on sunlight for nutrients. the reproductive stems of Malophylus will become larger as well. So large, in fact, that it will be the primary feature of this new plant. The new stem will be somewhat spongy and will release large amounts of gametes into the air, or water if the tide is high. The roles of male and female stems have been combined into one, where a single stem will release both male and female gametes. Male gametes will be released at a separate time from female gametes so that it does not breed with itself. This plant may be larger than Malophylus, but only up to 15 centimeters tall. Pollen plant is what Gyrophyllus will be named after. Tachypod may have found shelter in the early stages of the intertidal zone at high tide, but it will no longer be able to do so with so many predators about. For this reason, it may adapt to be fully terrestrial, where no predators currently reside. To do this, it will need to be able to breathe air. Like Canceriform, it will have next to no issue transitioning to air, as its spiracles will allow a direct absorption of oxygen through both medium. A kidney may develop to allow it to process water more efficiently, which is necessary as it is no longer aquatic. Its eyes may grow larger to better see its surroundings. With larger, more receptive eyes comes a larger, more receptive brain. This will allow the creature to hide from, or outmaneuver, anything chasing it. Separating its head from its body will allow for even greater mobility, and its legs may become longer and specialized for jumping, making it possible for it to flee to the Anarchaphylus littering the coastline. In the Anarchaphylus trees, it will be safe from nearly anything. Its color may shift to blue so that it may camouflage itself on the trunk. When reproducing, it will lay its eggs under the leaves of Anarchaphylus, where they will be safe and protected from the sun. The eggs will adhere to the leaves using a sticky birthing fluid produced by the mother. Clutch sizes will range from 20 to 50, and the offspring will live to be about 1.5 years old, growing up to 5 centimeters in length and weighing almost nothing. This creature will feed almost exclusively on Gyrophyllus, as the Anarchaphylus bark is too dense for it to chew, and Gyrophyllus is plentiful everywhere. This descendant of Tachypod will be called Almopod, or jumping foot. With Almopod feeding on Gyrophyllus, it may become beneficial for the two to develop a symbiotic relationship. Gyrophyllus may begin producing a sweet substance that is high in nutrients. This will attract Almopod, which would be an excellent candidate for a pollinator. The new plant may develop stacks of bolls that contain the sweet substance, known on Earth as phytodelmata, or plant-held water. The flesh of the bolls may develop a toxin that prevents it from being eaten. On the rims of each boll will be a thick mat of pollen, which will stick to the creature and travel with it to new locations. It will continue to grow on rotting material, but it may occasionally find itself on sediment. For this reason, its leaves will have lengthened to collect more sunlight during the day. This evolution will not be as common as Gyrophyllus, but it will be larger, with some growing up to 25 centimeters tall and 15 centimeters wide. This plant will be known as Gyrophyllus, or bull plant. Evolving alongside Gyrophyllus, Almopod will become specialized to eat the nectar from Gyrophyllus by externalizing a part of its digestive tract. Like a straw, this long tube will allow the creature to suck up nectar without any problem. With Gyrophyllus being sparse, the creature may develop a better method of locomotion. It may do so by converting its second set of limbs into basic wings. This will allow it to travel long distances in a single jump, much like a grasshopper. To avoid predators, it has evolved to be nocturnal, and to blend in with the night, it has become dark in color. Because of this creature's nocturnal habits, Gyrophyllus will only produce nectar at night. During the day, it will burrow under the roots of plants, where it will sleep. It would be difficult for this creature to find a mate based on luck, so the male of the species may begin to rub its new wings together in a process called stridulation. This will create a noise that will alert females to his location. The pair will mate, and the female will lay her eggs underground, where they will likely not be disturbed. clutch sizes range from 15 to 30, and the offspring will live to be 1.5 years. The maximum potential size for this creature will be 3 centimeters length, and almost nothing in weight. We will call this creature Nectarophagus, or Nectar Eater. Before we move on to Nectarophagus's predator, I'd like to talk about a plant that would be useful for said predator. Rhizophilus may transition fully to land, growing longer leaves and stronger roots. It may grow up to 50 centimeters in height in locations with lots of sunlight, but in dimmer areas it may grow up to only 20 centimeters. This plant will be known as Macrophylus, or long plant. Hiding in Macrophylus is a descendant of a Formapod. Its legs will have become specialized for gliding so that it may give chase to its prey if necessary. Its rear legs will have become more powerful to allow for a large jump, and a membrane has formed between each limb. Its eyes have become larger in proportion to its body to take in more light. This will allow it to hunt nocturnally when its prey is most active. To better hunt for its prey, it may develop a hole with a thin membrane on either side of its head to allow for sound to be received and processed. This will allow the creature to locate its prey, Nectarophagus, much easier, though it will still rely on its excellent vision to actually spot its prey. Because it hides in Macrophylus, it will be blue in color. The creature will reproduce in the same way as a Formapod, its ancestor, though its eggs will be much smaller in proportion to its body and in larger quantity, with clutch sizes of 3 to 8. The offspring will grow up to 10 centimeters in length, weigh up to 10 grams, and live to be 3 years of age. This small creature will be called Pedipod, or flying foot. An Gyrophyllus may fully transition to land, straightening its trunk and growing much larger. This new form may develop new branches of leaves, which will aid in absorbing sunlight. Besides these changes, it is very similar to its previous form. We will call it Malophylus, or big plant. Phylphagus is the most likely candidate to feed on Malophylus, as it is the largest herbivore on land at this time. It may grow quite large, up to 2 meters in height, and weigh up to 250 kilograms. Its mandibles will become even sharper to tear the leaves of Malophylus. This will also allow it to defend itself from predators, though it is very slow and won't be able to fend off threats for long. To reach its food, it may separate its head from its body, allowing for greater range of movement as well as granting the ability to more easily spot predators. In order to support such a large head, however, it will need a sturdy anchor for its neck muscles to attach to. This may come in the form of a thicker vertebrae near the front of the body. It will need to properly support its body weight as well, and so may fuse its limb girdles with its front and rear ribs, creating a sort of frame around the inside of the body. This will make the creature very rigid, but will be suitable enough for now. Though its diaphragms are more effective at drawing in air than its Formapod counterparts, it will need even more oxygen to properly fuel its body. For this reason, the creature may develop a second breathing tube on either side of its body. It will have also developed a second stomach to better process the tough material that makes up Malophylus. This creature may live to be 15 years of age. Zeraphostoma is what this creature will be called, for its razor mouth. Recall, if you will, Microtraumastoma, the parasite of the seas. It may follow other creatures to land, latching on the likes of Phylphagus and a Formapod. To do so, it may become even smaller, and may lose its gills entirely in favor of absorbing oxygen through its skin. Its head may separate from its body, allowing it to swell up to 10 times its normal size. The inside of its mouth may extend into a tube, like Nectarophagus, to allow it to more easily sip blood. What used to be its fins may become small legs with tiny claws at the end to allow it to better latch onto its prey. It reproduces by waiting for its host to mate, then transfers itself to the other creature. It will then mate with any others of the same species it might find. A fertilized female will lay her eggs directly onto the body of the host. generally in a hidden location such as under a limb or tail. The eggs will be coated in a sticky substance, similar to Almopod, which will allow them to adhere to the host's body. This creature may grow to be half a centimeter in length and may live for a little over a year. This parasite shall be called Cryodenchoma, or hidden bite. The final creature for today's episode descends from a Formapod. But first, I'd like to talk about a representative from the octobrachid line. Macrosoma may transition to land as a detritivore, boring its way through the sediment and devouring the carcasses of the dead alongside Gyrophyllus. It may lose its hook, as it no longer needs to anchor itself, and it may become smaller, as it is no longer in the deep sea. Its skin may thicken and take on a brown color to match the soil to avoid being eaten. It will continue to have no through-gut, which means that after a meal, it will need to expel the waste from its mouth. To better transport absorbed nutrients through the body, it may develop multiple hearts along its body. Reproduction will change from broadcast spawning to asexual reproduction, splitting in half lengthways. This will make it much easier for the creature to reproduce, as it will not have a medium that it can broadcast through. It will grow to be roughly 15 to 20 centimeters in length, and may live up to 2 years. The creature will multiply rapidly on land, becoming a common sight on Miira. As it is very similar to Earth's worms, it will be called Sculiciform, or worm form. Finally, we come to the last creature of today's episode. A Formapod may forego the sea in favor of larger prey, Zeraphostoma. Its mandibles will become quite large and viciously sharp to better tear through flesh, and its rear legs will become even more specialized in leaping at prey. A blue hue will help it hide in Macrophylus, where it will stay completely still until the moment to strike arises. Because a Formapod already encases its young in a hard shell, it will be easily able to lay its eggs on land. When it comes time to do so, the female will make a burrow under Malophylus. There, she will protect her eggs from anything that comes near. The offspring may grow up to 2 meters in length, 75 centimeters in height, and 50 kilograms in weight, and may live up to 8 years of age. Anadropod, or ambushfoot, is what this creature will be called. These evolutions take place over the course of 100 million years, bringing the timeline to 2.7 billion years ago. In the next episode, we will talk about climates and how they affect the creatures of Miira. If you're interested in seeing what kinds of creatures might evolve in future episodes, or have suggestions or ideas of your own, considering joining my Project Miira Discord server. I'll leave a link to that in the description below. I hope to see you there.